Hi everyone, so in this video we are again going to be talking about systems of inequalities. Just this time we're going to be taking it a step further, and by the end of this notes we are going to be talking about maximization. So to start, we have a few definitions up here. So first off, a corner point is a point in the solution region that is the intersection of two boundary lines. So whenever we were actually graphing systems of inequalities, we always said that there was one shaded region that was our final solution. And whatever points are in the corners of that shaded shape, those are corner points. The next two definitions go with each other. We say that the solution region is bounded if it can be enclosed within a circle. We say that it's unbounded if it cannot be enclosed within a circle. And we'll see examples of that in a bit. So this is going to start out very similar. We're going to solve the system graphically, but then we are going to state the coordinates of each corner point, and then we are going to indicate whether it is bounded or unbounded. All right, so let's go ahead and look at number 1. So number 1, we have 2x plus 4y is less than or equal to 20, and 2x plus 2y is greater than or equal to 14. Now just like before, go ahead and color code these. Now, we also have one more equation at the bottom, and we will talk about that after we graph our other two. So first off, 2x plus 4y equals 20. We need to graph that. Well, in this case, y is not solved for yet. Right? So again, I'm going to do this by solving for y, and then graphing it using the slope and intercept. If you want to graph it by using both intercepts, or if you want to make a table, whatever you want to do is perfectly fine. I'm going to do it by intercept, so we're going to start, by slope and intercept. So we're going to start by moving that x over so we can start solving for y. So we have 4y equals negative 2x plus 20. And we can divide everything by 4. So we get y equals negative 1/2 x plus 5. So our slope is negative 1/2, and our y-intercept is going to be 0, 5. So we're going to start up at 5. Then go down 1 over 2, down 1 over 2. Then we're going to draw the line through it, and all of these are less than or equal to or greater than or equal to, so that means we're going to be using solid lines for all of these. So I'm going to go ahead and draw that solid line, and then we're going to go ahead and shade it as well. So in this case, it is less than or equal to, so that means that we are going to be shading below this line. And by the way, you might notice already that I only gave you 1/4 of the normal graph, and I promise we will get to the y in a minute. All right, so that's one down. Let's go ahead and graph the second one. So we got 2x plus 2y equals 14. Again, I can start this off by subtracting 2x from both sides. So we have 2y equals negative 2x plus 14. Then we can divide both sides by 2, and we get y equals negative x plus 7. So our slope is negative 1 over 1, and our y-intercept is 0, 7. So I'm going to put a point up here at 7. I'm going to go down 1, right 1, over and over. Then I'm going to draw the line through it. So here's our line. And now this one says greater than or equal to. So that means we are going to be shading above. So I'm going to shade above this line. And there we go. All right, now let's get to those last two. X and Y are greater than or equal to 0. So this one's actually talking about two separate inequalities. This is just kind of shorthand for it. It's saying that X is greater than or equal to 0 and Y is greater than or equal to 0. Well, if we did graph that, X is greater than or equal to 0 is just the Y-axis. Y is greater than or equal to 0 is the X-axis. And if we want X is greater than or equal to 0, that means we want everything to the right of the Y-axis. Y is greater than or equal to 0 means we want everything above the X-axis. Essentially, it just means that we want only the first quadrant. So whenever we are shading our final answer, we are just going to be paying attention to the first quadrant. So here's what I mean by that. Remember, green is where our two overlapped. So the region that we're going to shade is here, but I'm not going to go to the green that is down here. I'm going to stop right at the X-axis because we want everything just above that. So only that little triangle is our actual solution region. All right. Next up, it asks for two more things. It asks for the corner points, then also said to state whether each solution is bounded or unbounded. So if we do part B real quick, the corner points, if you look, this triangle has 3 points. It's literally just the corners of the triangle. So we have 4, 3, 7, 0, and 10, 0. Those are our 3 points. For part C, to be able to tell if it's bounded or unbounded, you just see if you can draw a circle around the whole thing. Well, in this case, sure we can. There's a circle. The entire triangle fits in that circle. Again, it's not a perfect circle, but you get the idea. We can draw one around it, right? So since it can fit in a circle, we say that this is bounded. All right, that is it for example 1. So let's go ahead and move on to example 2. Now, you might notice something about example 2 and example 3 and 4 that we're about to do as well. For all of these, it's the same exact inequalities except for the inequality sign itself. The first one had less than or equal to and greater than or equal to. This one has both less than or equal to. So luckily, that means we're not going to have to get the slope and resolve for them every time. We already know what they look like, so we can go ahead and just draw these out again. So here is our first one. I'm going to draw the line. And I'll also go ahead and draw out the second one. And remember, these are the colors I'm using. So the second one started up at 7, went down 1 over 1. So we can get this drawn as well. And draw the line through that. And the thing that is going to be different this time is going to be the shading. So don't forget, X and Y axis still there. Everything's the same except for that shading is going to be different. So for our blue one, it is less than or equal to this time, which means we're going to shade underneath the blue. There we go. And don't worry about going outside the axis whenever you're just shading one of them. It's our final answer that we're worried about not going beyond those axes. So if it spills over beyond them before that, no big deal. All right, then for the yellow one, it's also less than or equal to, so it's also going to be under this yellow line for the shading. And then we can go ahead and shade our final region again. So again, in this case, we have this shape in the corner. I usually like to just start with those kind of outline of the shape, and then just kind of roughly fill in the middle. That's no big deal. But we do want to at least see that outline pretty well. All right, so that is our final shaded region. So now we are going to, for part B, look for our corner points. So in this case, we actually have 4. So we have a corner here, 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 and here. So that's at 0, 0, 0, 5, 4, 3, and 7, 0. For part C, again, to see if it's bounded, just see if you can draw a circle around it. We can, so it is bounded. All right, let's look at another one. And again, it's going to be the same 2 lines. So to start off, I'm going to go ahead and just draw out the lines for both these last examples just to save us some time, that we can focus on the shading and finding the corner points, because that's really the idea of this one, is how to do those things. So I'm going to go ahead and draw all of these lines real quick. All right, I have both lines drawn for these last 2 examples. Luckily, with some editing magic, you don't have to sit through that again. But we are going to talk about the shading. So for example 3, both of them are greater than or equal to, meaning both of them are going to be shaded above. So if we start with the blue line, we are shading above here. And then for the yellow line, same thing, still shading above. All right, and so where is our overlap? So again, I usually like running along the sides of the shape first, just so those kind of pop out a little bit more. We can see our corners a bit easier. and it's going to be shaded out this way. Okay, so for part B, we're going to find our corner points. So in this case, there are 3. There's one right here, here, and here. Remember, it's just the corners of that last shaded region that we did. So those are 0, 7, 4, 3, and 10, 0. For part C, we are going to see if it's bounded or not. And keep in mind, even though I couldn't actually shade it that far, this shading doesn't stop. There's nothing boxing it in. There's no more sides. So no matter how big of a circle we try to make, this shading still goes outside of that circle. So we can't contain this shading in a circle. So because of that, we call it unbounded. Another way to think of it is this shaded region just keeps going forever. And if it keeps going forever, then it is unbounded. All right, let's try the last one. So for the last one, for the blue line, it is greater than or equal to 20, so that means above the blue line. So we got that shaded. Then for the yellow line, it is less than or equal to, so that means below the yellow line. All right, so again, we're going to be looking for our region that is green, and that is this triangle right here. So if we look for our corner points, we have 3, 1, 2, and 3 corner points. So those are 0, 5, 0, 7, 4, 3. And we can definitely draw a circle around this one, so it is bounded. All right, I'm going to go ahead and cut this video off right here. In the next video, we are going to have a couple more examples of trying to find this region and find corner points. And then we are going to actually try to use this for maximization. So I will see you in that video. Thank you.